Hello, guys. My name is Desmond, and I welcome you to my YouTube channel. Ladies and gentlemen, for today's lesson, we'll be looking at question 6 of Physical Sciences, paper 1. And this lesson is suitable for grade 12s. Okay. And again, most importantly, ladies and gentlemen, it's also suitable for those who are upgrading their physical sciences. So, ladies and gentlemen, it's going to be one of those interesting lessons where I'm going to make sure that you learn as much information as possible. And again, I'm hoping to reveal all the strategies and tricks related to this chapter. So, what I'm going to do is to quickly read through the statement, go through the questions, answer each and every question, accompanied by additional information where necessary. And most importantly, ladies and gentlemen, I'm going to show you exactly where you score some marks. Okay, remember guys, at all times, especially for your exam papers, you are advised to start each question on a new page. Very much important, ladies and gentlemen. It helps us at the marking center to see exactly where is the start and where is the end of your question. Okay, so we don't want a situation where you've got a question, you just skip a line and you start a new question, because in case if there are some cancellations in your questions, and again as a result of your handwriting, because some of you guys, your handwriting is not that neat, so you might find that the next question is part of your final answer. So you find that we are not able to see that you actually started a new question. So it becomes some of the problems that we encounter at the marking center when we're marking your exam papers. So, ladies and gentlemen, please do make sure that you write neatly, okay? It's very much important, ladies and gentlemen. So, guys, without any waste of time, I'm quickly going to read through the given statement. As you can see, I've tried to draw a diagram there. So, from time to time, we might need to refer to that diagram that I drew by hand over there. So, ladies and gentlemen, we're given a statement. Let's carefully read this statement, and try to familiarize ourselves with the content given in that statement. A train approaches a station at a constant speed of 20 meters per second, with its whistle blowing at a frequency of 458 hertz. Okay, ladies and gentlemen, the information that we collect from that first sentence is very much important. Before I reread that statement, please do make sure that if necessary, after I've read each and every sentence, just try to make some notes and compare your notes with what I'm going to explain, okay? Because remember, ladies and gentlemen, it doesn't necessarily mean all the information that I'm providing, it's all that you need to know, or it's all that you need to bear in mind, or is the limit in terms of the manner in which you should interpret the given statements. Do not limit yourself based on the information that I provide, okay? So in case if there's something that I haven't mentioned and you've noted it down, please do consider yourself very much lucky, because you are able to notice some extra information which may not be indicated by whoever who's training you on how to approach past exam papers. Okay, remember, ladies and gentlemen, this question paper is posted on my Telegram channel. That's where I post previous question papers, and not only for the subjects that I do, but for all the high school subjects. Very much important, ladies and gentlemen, that if you've got a Telegram account, you do go check out that Telegram channel. Okay, so an observer standing on the platform, ladies and gentlemen, hears a change in pitch as the train approaches him, passes him, and moves away from him. Okay, so ladies and gentlemen, remember, this is my very first question that I'm doing related to this chapter. So what I'm going to do by the end of this lesson, I'm actually going to prepare a complete lesson where I cover all the most important things that you need to know in relation to this chapter. So I'll make sure to post that lesson before you start with your examinations, so that you are able to then make sure that you have all the weapons that you need in order to tackle questions related to this chapter. Okay, very, very much important, ladies and gentlemen, that you check out my status on my WhatsApp, because that's where I do the updates. So I'm going to post a link for that particular video so that you can catch it live. And again, if you failed, you can still catch up. Okay, so the advantage of watching these lessons while they premiere is because, or to watch live lessons is because I'm able to give you an urgent attention. So in case if you've got a question, I can quickly attend to that particular question. But instead, if you watch it at a later stage, it's still fine. You can still post questions on the comment section. Then at a later stage, when I go through the questions, then I'll just quickly give you a response. Okay, so ladies and gentlemen, for the last time, I'm just going to quickly read through the given statement, then we'll just note down all the necessary information. Okay, so a train approaches a station at a constant speed of 20 meters per second with its whistle blowing at a frequency of 458 hertz. So, ladies and gentlemen, the information that we're actually collecting from that first sentence is that we've got a train. As you can see there, ladies and gentlemen, I try to draw that train. Okay, so this is just the head of a train. So they're saying this train is approaching a station. Okay, so assuming that this is a station, ladies and gentlemen, assuming that this is a station, so that train is actually moving or approaching the station at a constant speed of 20 meters per second. Okay, very, very much important, ladies and gentlemen. And remember, guys, remember, this speed is a constant speed, meaning throughout the journey of that train, as it approaches, passes, and moves away from the listener or the station, it's moving at a constant speed of 20 meters per second. Okay, very, very much important, ladies and gentlemen, that you take into consideration this kind of information. Okay, so again, ladies and gentlemen, this train has got its whistle blowing. Okay, very, very much important, ladies and gentlemen. It's blowing its whistle at a frequency of 458 hertz. So this is the information associated to this train. Okay, very much important, ladies and gentlemen, that you write down all this information. So remember, guys, frequency is measured in hertz. Okay, so for some reason, if you see a value or any magnitude and you see Hz, before you can even read the whole statement, you should be aware that there's a value or magnitude for frequency. Okay, so you'll be reading the statement with the aim of trying to figure out for which frequency is that magnitude. Okay, so ladies and gentlemen, before I go deep into dishing out information, please, ladies and gentlemen, do allow me to say it's very much important that I say it's very, very much important, because, ladies and gentlemen, what I'm about to say is massively important. Okay, guys, a day without learning something new, it's a day wasted. Okay, so please do make sure that by the end of each and every question, or by the end of this question, ladies and gentlemen, make sure that you learn something new. Okay, so guys, as we continue, I just wanted to indicate that we've actually got the most important information in relation to that train. Okay, so it's a speed, which is a constant speed of 20 meters per second. We've got the frequency, which is emitted by the whistle as the train is approaching either the station or the listener. Okay, ladies and gentlemen, frequency is measured in hertz, speed or velocity in meters per second. Very, very much important, ladies and gentlemen. So, guys, an observer. So this is actually an observer. Okay, an observer standing on the platform. Which platform? This platform, ladies and gentlemen, which is the platform on the station. Okay, so this observer who is standing on the platform hears a change in pitch, ladies and gentlemen, as the train approaches him, passes him, and moves away from him. Okay, so guys, remember, it doesn't necessarily mean this train is only coming from that direction, moving in that direction. Very, very much important, ladies and gentlemen. I only decided to draw it that way. Okay, so anyone could draw it in the opposite way, such that the train is moving from that direction, moving in that direction. Okay, very, very much important, ladies and gentlemen, that you take into consideration that the direction in which the train is moving, in this case, it's not really a real deal. Okay, so ladies and gentlemen, I just want to quickly indicate to you that we've got, let's say this is stage 1 or phase 1, stage 2 or phase 2, stage 3 or phase 3. Okay, so guys, we've got the first stage, which is where the train approaches an observer. Okay, so here the train is actually approaching an observer. Okay, very, very much important, ladies and gentlemen. Obviously, as this train is approaching the observer, ladies and gentlemen, they've just indicated that he hears a change in pitch. Okay, so obviously you are having compressed wavelengths as this train is approaching him. Okay, so that means the noise of the whistle is actually increasing. This is practical, ladies and gentlemen. If a car, which is the driver, let's say it's the driver playing a music, you know very well, ladies and gentlemen, that as the car approaches you, the sound of that music is actually increasing, and as it actually passes wherever you're standing, ladies and gentlemen, at that point, that's where the frequency registered by the listener versus the frequency emitted by the source are the same. Okay, so ladies and gentlemen, that means the amount emitted by that source and by the amount registered by the detector or an observer who's listening is the same. There's no change in pitch. There's no change in wavelength. Okay, so it's more like you are the same as someone who's actually in that particular source. Okay, but the moment, ladies and gentlemen, that particular source moves away, which is at this stage where it's actually moving away from an observer. That's where the wavelength are now increasing, ladies and gentlemen. The wavelength are increasing. What does it mean? So it means the sound is now decreasing. Okay, so ladies and gentlemen, I've just indicated that I'm going to prepare a complete lesson where I cover all the necessary information that you need to know about before you start with the previous questions, and most importantly, just before you start with your exams, ladies and gentlemen, because I assume by the end of each and every lesson that I conduct, you go to my my Telegram channel to go through the question papers that I've posted, assumingly you do treat those questions. Okay, so guys, I think I've tried to actually explain all the relevant information required for us to be able to tackle these questions. Okay, so some of the information we might discover as we continue with the questions. Very, very much important, ladies and gentlemen, that you fully understand what is given on the statement. Okay, so guys, remember, I've just indicated that the information that I provide doesn't necessarily mean that I've actually provided all the necessary information, and anything else that I haven't mentioned might not be important. Okay, so I know some of you, ladies and gentlemen, some of you who have done what I was taking long to explain, you've actually noted down the velocity of the observer or the velocity of the listener. Very, very much important, ladies and gentlemen. The moment they give you the speed or the velocity of the source or the moving train, ladies and gentlemen, at the same time, you ask yourself, what happens to the listener? What happens to the observer? What happens to the detector as far as speed is concerned? Ladies and gentlemen, they've just said a train is approaching a station at a constant speed with its whistle blowing at that frequency. An observer, ladies and gentlemen, standing on the platform. Very, very much important, ladies and gentlemen. The observer is standing on the platform. What does it tell in terms of the velocity or the speed of the observer? Guys, we haven't read somewhere where they are talking about the speed of that observer. Okay, so which means this information standing on the platform, it's enough for us to conclude that the velocity or the speed of the listener or the observer is 0 meters per second. Very, very much important, ladies and gentlemen. Why am I confident that the speed or velocity of the listener is 0 meters per second? Is because, ladies and gentlemen, they just indicated that the observer or an observer is standing on the platform, and from there they never said anything regarding the speed or the velocity of the observer. Okay, very, very much important, ladies and gentlemen, that you take into account this kind of information. This is not the only way in which they can represent a stationary or a standing observer, ladies and gentlemen. They can, for example, give a situation where there's a car accident and an ambulance is approaching the scene. So, ladies and gentlemen, you should be aware, very, very, very much important that you should be aware that there are different ways in which they can explain or guide you in terms of the velocity of the listener. Okay, of the listener, of an observer, or a detector, whatever that it is. It depends on the information or the scenario that you're given. Ladies and gentlemen, let's now continue. So I assume you fully understand that. So I did it on purpose, ladies and gentlemen. I just explained everything and left out that information regarding the observer. Why? It's because I wanted you to actually notice that not all the information that I'm providing is limited, or it's all that is necessary for you to to reveal, or ladies and gentlemen, to dish out to you. You can go beyond the information that I've provided. Okay, so guys, let's now start with our very first question, ladies and gentlemen. So the question, which is 6.1, says, name the phenomenon that explains the change in pitch had by the observer. And this question, it's allocated 1 mark. Ladies and gentlemen, in this case, examiners are not only interested in you providing an answer. Guys, it's very much important that when you start each and every question, you know the chapter of that particular question. Okay, they cannot mix this chapter with that of, as an example, ladies and gentlemen, vertical projectile motion in one dimension. Okay, I'm just giving that as an example to say they might not really incorporate or combine this chapter with that of work, energy, and power. Okay, very, very much important, ladies and gentlemen. So, lastly, guys, they might not combine this chapter with that of electric circuits. Okay, so there will be a chapter for electric circuits. There will be a chapter for vertical projectile motion. There will be a chapter for work, energy, and power. So, ladies and gentlemen, learn to differentiate those type of chapters, okay, so that you are able to then answer questions related to that particular chapter. For example, in this case, guys, they say name the phenomenon, okay, that explains the change in pitch had by the observer. Okay, so obviously some of you already know an answer to this question, but what I wanted you to notice, ladies and gentlemen, is that it's very much important that you really know and understand the chapter that you're about to start with. Okay, so for the purpose of answering this question, an answer to that question, ladies and gentlemen, it's Doppler effect. So what is Doppler effect, ladies and gentlemen? It's the phenomenon. Okay, it doesn't necessarily mean that I'm actually giving the definition of a Doppler effect, but I'm just trying to indicate to you that this may be a question in multiple choice type of questions, which may be asked to you such that you need to choose from multiple choice or the list given, and you then need to choose Doppler effect as an answer for that question in the multiple choice type of questions. So that means you should be aware that a phenomenon that explains the change in pitch had by the observer. Can you see how general this statement is, ladies and gentlemen? Phenomenon that explains the change in pitch had by the observer. Even if I didn't draw all of that information, ladies and gentlemen, even if I didn't read all of this given statement, ladies and gentlemen, and only read the question, you should be able to know that the phenomenon that explains the change in pitch had by the observer, it's Doppler effect. Okay, so remember this question is allocated just 1 mark. So let me just write down, this is question 6, and you are advised to start this question on a new page. Very much important, ladies and gentlemen. So now we are still on question 6.1. In answering the question, ladies and gentlemen, just write 6.1 and say Doppler effect. Very, very much important, ladies and gentlemen. By so saying, you score yourself 1 mark. Okay, so we will make sure that you get that mark, ladies and gentlemen, because you've actually answered, you've actually fully answered the question. Okay, so guys, I think we can now move to the next question. Okay, very, very much important, ladies and gentlemen, that we write all these answers so that in case if you're writing down, you can just note it down. At a later stage, when you prepare for your exams, you can still refer to the same information. So, ladies and gentlemen, there is a question which is 6.2, and the question says, calculate the frequency of the sound that the observer hears while the train is approaching him. Use the speed of sound in air as 340 meters per second. Very, very much important, ladies and gentlemen, that you fully understand what the question wants you to calculate. Okay, very, very much important, ladies and gentlemen. There are situations where you might need to calculate whatever that the question might want you to calculate, but in a different scenario. Can you see? In this case, they say, this is a specification, ladies and gentlemen. They say while the train is approaching him. So that means you might also be requested to calculate, let's say, for example, the frequency as the object is moving away from him or from an observer. Okay, very, very much important, ladies and gentlemen, that you take into account how the question is asked. Very, very much important, ladies and gentlemen, that you take into account what the question wants you to do. Okay, so they wouldn't give you a mark, ladies and gentlemen, if you do calculations while your calculations are actually referring for the train while moving away, because you are not following instructions given within the question, ladies and gentlemen. Please do make sure that although the substitution might be the same, but as a marker in the marking center, if I'm working on your paper, ladies and gentlemen, or your answer sheet, you give me an impression that even on the upcoming questions, you do apply your mind. It's not like you just borrowed a substitution or a question from your friend next door. Very, very much important, ladies and gentlemen. Please give me an impression that you fully understand what you're dealing with. Okay, so by having your answer in order, it also gives me the confidence to pay full attention into your answer sheet. Even if you don't, ladies and gentlemen, our work is to try and look for where we can give you some marks when you deserve to get those marks. Okay, we don't just give you marks, we give you marks based on how you answer the questions. Okay, so ladies and gentlemen, for the last time, I'll just read the question, which says, calculate the frequency of the sound that the observer hears while the train is approaching him. Use the speed of sound in air as 340 meters per second. Okay, so we've got the speed of air. Let me just say the speed of air. This is the same as V, ladies and gentlemen, on that formula, which is 340 meters per second. Okay, very, very much important, ladies and gentlemen. So I always tell my learners that this chapter is not really difficult, ladies and gentlemen. You only score maximum marks if you fully understand the scenario. There's no need for the examiner to give you a diagram. You can visualize from the given statement. Okay, that's what I'm trying to do when I draw that diagram. That when you're given a statement similar to this one, if you are quick enough, ladies and gentlemen, do not just try to have everything in your mind. Okay, just try to quickly draw all the information that you can, write all the information that you can be able to write, and then from there, based on the questions and the manner in which questions are asked, and most importantly, the order in which questions are asked, they are going to guide you in terms of what to do as your first step in answering the question. Okay, so ladies and gentlemen, in this case, this is 6.2. So in this case, ladies and gentlemen, this is the formula that we'll be using. I just wrote it there so that we obviously, all of us know that formula is given also on your formula sheet. Let me just quickly check exactly where is that formula, because I know, ladies and gentlemen, some of you don't even take the effort to have a look at this formula sheet when you treat previous question paper. Some of you just straight away answer the questions and only wait to use this thing in exam. Please, ladies and gentlemen, try to familiarize yourself with the formula sheet, and not only the formula sheet but also the physical constants. Ladies and gentlemen, very much important that you familiarize yourself with all of this information. Okay, so guys, let's check. There we've got equations of motion. Here is force. Here it's work, energy, and power. Here we've got wave, sound, and light. Here we've got electrostatic circuits. Let me see, it's electrostatic. Here we've got electric circuits. We've got alternating currents. So our formula should be somewhere there. Okay, waves, sound, and light. We use these formulas, ladies and gentlemen. They just give you all the formulas related to that chapter. Based on the question that you're dealing with, you have to choose which one is the relevant formula to use. Okay, so here's the formula, ladies and gentlemen. This is the formula that we'll be using for this question. Okay, so guys, I've already written down that formula over there. You can see. Let me just quickly go back to that question. Where is that question, ladies and gentlemen? This is our question 6. This is where we are. So remember, ladies and gentlemen, if you are not able to see exactly what's written there, I'm sure on your mobile at the top right corner there are 3 dots. If you can just click there on those 3 dots, you can also click on quality. Then down there should be advanced. Then you can just click on I think it's 480 or 300 and something p. Then as soon as you click there, then the quality is going to adjust itself and you'll be able to read everything that is on the screen. And again, ladies and gentlemen, this question paper should be posted on my Telegram channel, but I assume you are able to clearly see everything on the screen. So ladies and gentlemen, let's now start with question 6.2. Okay, so obviously this is the formula that we'll be using. There is V, this is plus or minus. We've got VL over there, over, this is V plus or minus VS multiplied by FS. Okay, very, very much important, ladies and gentlemen, that you fully understand this formula. Okay, so in terms of the plus or minus, obviously, ladies and gentlemen, this depends on the velocity of the listener relative to the velocity of the source. Okay, so that means that plus or minus is not really for that V. It's not really for that V. That V, it actually refers to the speed or velocity of the air. Okay, so obviously there we are not interested in the direction of the velocity of the air. Okay, so the plus or minus, it's based on the velocity of the listener or the velocity of an observer relative to the velocity of the source. Very, very much important, ladies and gentlemen. We also have the frequency of the listener. So this formula, all of this formula, it's actually equal to the frequency of the listener. Okay, so ladies and gentlemen, the listener should be able to register the frequency as a result of the source. Okay, very, very much important, ladies and gentlemen. So that means the source must emit a sound which the listener must register that sound. And what do they register, ladies and gentlemen? We are talking about the frequencies. Okay, so that means the sound emitted by the source will release certain amount of frequency which is going to be registered by the listener or an observer. Okay, and again, it could be a detector which detects sound. Very, very much important, ladies and gentlemen, that you understand this formula. Okay, so now let's have a look at the information that we're given, and then from there try to substitute into the formula and proceed with our calculations. Ladies and gentlemen, it's very much important that you fully understand exactly what the question wants you to calculate. Okay, remember, they want you to calculate the frequency of the sound. Okay, the frequency of the sound that the observer hears. Most importantly, while that train is approaching the observer. Okay, taking into account that the speed of velocity of the sound in air is 340 meters per second. Okay, very, very much important, ladies and gentlemen. So that V and that V is the same, okay, in terms of magnitude or in terms of the value. Okay, so ladies and gentlemen, can we do it the primary way, where we say a given data? So we know, ladies and gentlemen, we've got a frequency. Let me just say in that order to say frequency of the listener, it's equals to, then you're able to put a question mark over there, because that is exactly what the question wants you to calculate. Okay, very, very much important, ladies and gentlemen. So now, what is that V over there? Okay, then we know, ladies and gentlemen, we know V. V refers to the speed of sound in air, and is given as 340 meters per second. Okay, very, very much important, ladies and gentlemen, that you write the units for speed or velocity. Okay, so ladies and gentlemen, remember, this V is the same V there and there. Okay, so now what is the V of the listener, ladies and gentlemen? What is the velocity of the listener, or velocity of the observer, or the velocity of a detector? Ladies and gentlemen, it doesn't really matter whether it's a detector, whether it's an observer, whether it's a listener. In this case, I'm just saying all of this so that you are aware that it could be an observer, it could be a listener, it could be a detector, or whatever it could be. Okay, so we're just trying to explore all the information relevant to this chapter. So, ladies and gentlemen, we know the velocity of the listener is 0 meters per second. Okay, why? It's because on the statement they said an observer standing on the platform. So for that reason, it means the velocity of the listener is 0 meters per second, because he is standing. Okay, ladies and gentlemen, let's now talk about velocity of the source. Okay, V of the source. Ladies and gentlemen, it's very much important that you remember that there we talk about the velocity. which is measured in meters per second. Okay, so what is the velocity of the source? So a source could be an ambulance, a source could be a police van, a source could be a train. In this case, a source could be any moving car, a emitting sound. A source could be anything approaching the listener. So that means, ladies and gentlemen, you should be able to find out from the statement which one is the listener and which one is the source. Okay, very much important, ladies and gentlemen, that you are able to differentiate between the two. Okay, so velocity of the source is equals to 20 meters per second. Very, very much important, ladies and gentlemen. A constant speed of 20 meters per second is the speed at which the source is approaching the observer or the listener. Okay, so ladies and gentlemen, what else have we got on the formula? Remember, ladies and gentlemen, I'm not referring or asking myself what is it that we are given from the statement, but instead I'm saying what does the formula have? And then from there, based on what the formula has, I'm just checking through each and every quantity to see if we are given the magnitude of that particular quantity. Okay, so now let's talk about frequency of the source. Okay, frequency of the source. It's equals to, ladies and gentlemen, they've just said frequency of the source is 458 hertz. Okay, 458 hertz. Ladies and gentlemen, that means if a question wants you to calculate the frequency, you know your final answer should be in hertz. Okay, it doesn't really matter if they are saying the frequency of the listener or the source, but for the fact that a question said a frequency, then your final answer should be in hertz. Otherwise, if it's a velocity, ladies and gentlemen, if it's a velocity, then your answer should be in meters per second. Okay, very much important, ladies and gentlemen, in meters per second. So that means on this formula, ladies and gentlemen, you only have two quantities or two types of quantities, which is the velocity or speed and frequency. Okay, so it's either you calculate the velocity or you calculate the frequency. Ladies and gentlemen, please do not be confused by this information. So what matters the most is the type of that particular frequency that you'll be calculating. Is it the frequency of the listener? Is it the frequency of the source? Is it the velocity of the listener? Or is it the velocity of the speed? Guys, it's not only the velocity of the listener, the velocity of the source, frequency of the listener, or frequency of the source that the examiner might want you to calculate. Very much important, ladies and gentlemen. They can also want you to calculate the velocity of the speed of sound in the air. Okay, very much important that you notice that the speed of the sound in the air, ladies and gentlemen, it's measured in meters per second. Why? It's because it's a speed, it's a velocity. Okay, so guys, let's now quickly sort out this question. So I'm sure, ladies and gentlemen, some of you are done already with this question. I know you're already done. I've actually delayed quickly finishing with this question so that I give you a chance to try and solve this question, because I know some of you, ladies and gentlemen, you know exactly how to solve this type of questions, but you are not confident until someone you trust solve that particular question. So ladies and gentlemen, that's what I'm going to quickly do now. So let's substitute. So we've got f of the listener. This is what the question wants us to calculate. Okay, and I'm well aware, ladies and gentlemen, that your confusion only comes on that part over there. Okay, but not many of you are confused when it comes to that part. Okay, so this is equals to, ladies and gentlemen, in brackets, I like substituting in brackets because you'll never go wrong. What is the velocity of the speed in the air? It's 340 meters per second. So when I substitute it to the formula, there's no need to write the units. Okay, so obviously this is the value that I just substituted, ladies and gentlemen. Then here comes a question. Is it a plus or is it a minus? A very interesting question, ladies and gentlemen. Is it a plus or is it a minus? Ladies and gentlemen, because the velocity of the listener is equals to 0, whether you assume a sign over there to be a plus or a minus, guys, I'm going to give you a mark. So when we mark for your paper, ladies and gentlemen, especially with this type of questions, if you assumed the sign for the listener to be a positive, or otherwise if you assumed it to be negative, for the fact that you know that the velocity of the listener is equals to 0, either you choose to write a plus or a minus over there, we are going to give you a mark, ladies and gentlemen, because one thing for sure, over there, guys, over there, you won't just leave it blank, but you should write a sign. But remember, guys, between these two signs, there's always a suitable sign, matching 100% with that scenario over there. Okay, so guys, if I were you, I would use a positive sign. Why? It's because the question says a train is approaching the listener. Okay, so even though, ladies and gentlemen, the listener is stationary at that point, okay, but because there's a movement towards, okay, because there's a movement towards, ladies and gentlemen, it's more like somehow these two are approaching with each other. Okay, if for a split second I can open my eyes and I notice there's a train at that spot, and again there's a train at that spot, then I quickly close my eyes, and after say 3 seconds I open my eyes and I notice now these two things are closer to each other, ladies and gentlemen. What am I thinking in my mind? I know there's there's a movement where something between these two is approaching. Okay, so it's more like they are approaching with each other, unlike if it's moving away. Okay, if it's moving away, ladies and gentlemen, if for a split second I open my eyes and I notice these two in this position, I close my eyes for 3 seconds, then I open and I realize that train is somewhere there, then I'm aware that, okay, these things, they are moving away from each other. So if they are moving away from each other, I would use a negative sign over there. If they are approaching with each other, I would use a positive sign over there. This information that I'm explaining is based on the fact that you've got a velocity of the listener being 0. Okay, otherwise, if it's not 0, I might still at some point apply this information that I've provided. Okay, so ladies and gentlemen, I'm just trying to indicate to you that for someone who wrote a positive sign there or a negative sign, it won't make any difference to the final answer, or it won't negatively impact the final answer, because 340 minus 0 is still 340. 340 plus 0 is still 340. 40. Okay, so ladies and gentlemen, let's now substitute this part at the bottom. So obviously I've just explained that v, it doesn't change, it remains as it is. Okay, so now ladies and gentlemen, excuse me, so we need to choose between positive and negative, okay. So based on that information that I've explained to you, ladies and gentlemen, based on that information that I've explained to you, guys, is it a positive sign or is it a negative sign over there? Remember, we are now dealing with the source. Okay, we are now dealing with the source. Okay, so obviously, ladies and gentlemen, obviously, you know, the source is approaching the observer. Okay, the source is approaching the observer and it's not moving away. Okay, so let's make a choice, ladies and gentlemen. Let's make a choice over there to say we used a positive sign because it suits that scenario over there. Okay, so because I've got a positive sign at the top, ladies and gentlemen, it will be a negative sign at the bottom. So this is a 20 meters per second. Okay, so ladies and gentlemen, it's more like now if these are approaching with each other, then that's where you have a positive value there at the top, then the opposite is the truth in the denominator side. Okay, very, very much important, ladies and gentlemen, that you understand this kind of information. Okay, so the velocity of the source in this case is approaching the listener. Okay, so if it's approaching the listener, then we know at the top it's positive, then at the bottom it becomes a negative, and this is multiplied by the frequency of the source. Okay, and the frequency of the source is given to us as 458. Okay, very, very much important, ladies and gentlemen. So all that you do, guys, all that you do is just to punch all of this on a calculator. So let's see, you just do a fraction pattern, then in brackets you say 340, then you add 0 in brackets, then at the bottom open is 340, you close, you minus into it's 20, then you multiply 458, which is equals to 486.625, which can be rounded off to 2 decimal places as 486 let me see, 663. Ladies and gentlemen, what is the SI unit for what I'm calculating? Remember, I'm calculating the frequency. So frequency is measured in hertz. Okay, very, very much important, ladies and gentlemen, that you write the SI unit. Otherwise, if you just write that number, then we don't know what number it is. We're not sure if this is the final answer or this is just part of this and you forgot to multiply it by 458. We just don't know exactly what it is. But when you write hertz, we know you've reached your final stage of calculating the frequency of the listener. Okay, very, very much important, ladies and gentlemen. So now this is where you score your marks. Remember, this question is allocated 4 marks. Okay, so the reason why I like physical sciences, ladies and gentlemen, they just give you a mark for copying the formula from the formula sheet. Very, very much important, ladies and gentlemen. They give you a mark for copying. Okay, so again, they give you a mark for correct substitution. Very, very much important, ladies and gentlemen. The moment you identify the correct formula, make sure that you substitute correctly. because by just substituting correctly, ladies and gentlemen, you score some marks. That's how easy physical sciences is. You score marks for copying. What copying, ladies and gentlemen? Not just copying a friend next to you or a classmate next to you, but for copying the correct formula from the formula sheet. Okay, and next they give you some marks for substituting correctly. Very, very much important, ladies and gentlemen. And your last mark obviously comes from your final answer with the correct SI units. Ladies and gentlemen, it's very, very much important that as soon as you write your final answer, you don't forget to write the SI unit. Okay, very, very much important, ladies and gentlemen. So now let's move to the next question. I assume you fully understood how to answer this question. By the way, it was one of the easiest questions because the question was straightforward. They just wanted you to calculate the frequency of the listener, so it wasn't that much complicated. So ladies and gentlemen, let's now check out this question. It's 6.3. So the question says, how will the observed frequency change as the train passes and moves away from the observer? Write down only increase, decrease, or remain the same. Okay, one thing for sure, guys, because there's a moving object over there, then it means remains the same will not form part of the answer. Okay, then you just need to choose from those two. Very, very much important, ladies and gentlemen. You just need to understand what they are talking about. Are they talking about the frequency of the train, or are they talking about the frequency of the listener? This is the most important part, ladies and gentlemen. So in this case, they are talking about the observed frequency, the frequency of the listener, the frequency of the detector. Okay, so ladies and gentlemen, as the train passes and moves away from the observer. So they're just asking, ladies and gentlemen, as this train is at that stage, as it passes and moving away, will the sound heard by this guy increase or decrease? We've already confirmed that remaining the same or remains the same won't form part of the answer because that object is moving. Okay, so obviously, ladies and gentlemen, the sound is going to decrease. The frequency is going to decrease. What is it that is increasing? Is the wavelength. Just in case if a question is asked differently, the wavelength is the one which is increasing, but the frequency is decreasing. So in answering the question, you just say decrease. Okay, or you can just write it exactly as it is from the multiple choice. So you just write decreases, and remember this question was allocated just 1 mark. Okay, so this is how you score a mark for this question. So ladies and gentlemen, let's now quickly sort out the last question. It's not that much difficult, easy and straightforward. That's how it is. How will the frequency observed by the train driver compare to that of the sound waves emitted by the whistle? Write down only greater than, equal to, or less than. Ladies and gentlemen, give a reason for the answer. Very, very much important, ladies and gentlemen, that you understand exactly what they're talking about over there. So now they're talking about the train driver, ladies and gentlemen, assuming that this is a steering wheel, and then even though there might not be a steering wheel which looks like the one in the car, but this is our grandfather that they're talking about, ladies and gentlemen, who's driving the train, which is making a noise. Remember, this train is blowing a whistle. Okay, so ladies and gentlemen, as this train is moving and passing that gentleman over there. Ladies and gentlemen, how does the sound heard by our grandfather over there compare? How does the sound waves emitted by the train compare with what our grandfather is hearing over there? Ladies and gentlemen, remember, our grandfather is within that train, and as it moves, even the sound is moving with the train. So that means because he's moving with the sound, with the train, because the velocity of our grandfather is the same as the velocity of the train. Ladies and gentlemen, because there's no relative motion between the sound and between the source or the observer, there's no relative motion between the two, ladies and gentlemen. That's what I'm trying to say. To say between the source, which is that sound emitted, and again the observer or the train driver, there is no relative motion between the two. It's not like the train is moving faster and leaving the observer or the train driver behind. They are both moving at the same velocity, and for that reason it means the answer is equals to it. It cannot be greater than, it cannot be less than, but it should be equals to. Okay, and I've already given the reasons, if you understood, when I was trying to to interpret that statement, because it could be a bit tricky, ladies and gentlemen. So you just need to be patient with yourself. Try to think deep about the question, take your time, and come up with the correct answer. So in answering the question, ladies and gentlemen, you just say equals to. Okay, so you give a reason. You can say train has not necessarily just the train, but you can just say the train driver has the same speed or velocity as the whistle. This is an answer that you can provide as a reason to equals to. And again, ladies and gentlemen, you can still say no, or there's no relative motion between let's say between source or train driver. No, the observer is actually the train driver. Let me just say train driver, which is the observer. So the train driver is the observer and the source. So ladies and gentlemen, you can answer this question however you feel that it's easy, and then from there, by so saying, we are going to give you a mark over there and 1 mark for providing a reason. So this question is then allocated 2 marks. Okay, very, very much important, ladies and gentlemen, that you fully understand what I've been explaining to you. So guys, I thank you very much for joining. I hope you enjoyed this lesson as much as I did. And guys, if you have watched this lesson until this far, please do make sure to give this video a like, ladies and gentlemen. Please make sure to like the video, and again, if necessary, drop me a comment just to give me a feedback if the lesson was clear. In that way, I'm able to then up my game if necessary. Otherwise, I'm able to confidently do more of this kind of content, because it doesn't serve a purpose if I continue creating content or solving these questions, whereas I'm confusing you guys. So, ladies and gentlemen, thanks for joining. My name is Desmond, and I'm out.